Funding for this program was provided by the Annenberg CPB project.
By the National Science Foundation, America's investment in the future. By the American Society for Microbiology. And by the Office of Biological and Environmental Research of the United States Department of Energy. Additional funding was provided by the Arthur Vining Davis Foundations. This program has been made possible in part by the Corporation for Public Broadcasting.
As different as all organisms are, multicellular or single-celled, they all share similar chemical molecules like DNA. It is the DNA which determines how each performs a fundamental process, making and using energy. In other words, how they metabolize.
How do organisms survive in this fickle and competitive universe? Well, for one thing, we all need food. Chemicals we can break down and use as energy to build new cells. This apple works fine for me, but it wouldn't satisfy a hungry carnivore. Different organisms, different energy needs.
No matter what the habitat a microorganism may call home, all microbes are performing this one basic life process. A process we all must perform to survive and grow. Metabolism. Metabolism refers to the thousands of chemical reactions and physical workings of the cell. It is the flow of matter and energy.
I'm Jim Leinfelder. In this episode of Unseen Life on Earth, we'll explore a variety of energy-producing metabolic strategies. Strategies determined by the molecules shared by all organisms, DNA, the backbone of diversity, protein synthesis, metabolism, and life itself.
Cells are like chemical factories. They spend a lot of their time producing energy as ATP, adenosine triphosphate, the energy storage material of all life on Earth. They then use that energy to drive their chemical reactions. These chemical reactions are divided into two groups, catabolism and anabolism. Catabolism is the process of breaking down macromolecules into their smaller component parts. These components may either be further metabolized for energy or used as building blocks for making new macromolecules. This process of using the energy and simple building blocks to make new macromolecules for the cell is called anabolism. It is an organism's environment and the energy sources available in that environment that determine which energy-producing strategy is successful, and therefore which organism will survive. Organisms can obtain their energy in one of several ways, such as photosynthesis, the conversion of light energy into ATP, or chemolithotrophy, converting inorganic chemical energy, such as hydrogen gas or sulfur, into ATP, or fermentation and respiration, the conversion of organic chemical energy, such as organic waste or sugars, into ATP. They are different processes, but all can go on in the same environment, and some even in the same organism, at different times or under different circumstances. The way that life works is that primary producers, such as photosynthetic and chemolithotrophic organisms, use part of the ATP they produce to create carbon-rich compounds. Other organisms, consumers, break apart the bonds in these carbon-rich compounds to release the energy that has been stored. Primary producers, such as plants, form carbon-rich bonds, and consumers, such as animals and microorganisms, break them. It is one big cycle. Microbes, since they have been here longer, have evolved more ways to do it. In most of the world outside the laboratory, ecosystems are complex mixtures of organisms with different metabolic abilities that not only coexist, but function together to be more than the sum of the parts. Like this ecosystem, a wastewater treatment plant in Radford, Virginia. Despite all the hardware, it's metabolism driven. Waste materials coming into a wastewater treatment plant come from a vast array of people who eat different things and have different microbes and therefore excrete different things, as well as anything else that goes down the sink or toilet.
Throughout this plant, there's a frenzy of metabolic activity, but we're really here to focus on one, respiration. And to help me with that is Dr. Nancy Love, a professor of civil engineering at nearby Virginia Tech, and you're really here to talk
activated sludge.